G'day everyone, thanks for joining into the latest instalment on chapter 12 on surds. This one is called Rationalizing the Denominator. Now we've heard these types of terms before. Rationalizing, remember in chapter 12.1 we talked about irrational and rational, surds being irrational and other numbers being rational. We want things to be rational, and the particular type of thing that we want to be rational is the denominator. So the denominator, remembering from year 7 from fractions, the denominator being the number down the bottom. So if we get 1 on root 5 for instance, we want the denominator to be rational. Currently it's not rational. Now I've just had to think about why we actually want the denominator to be rational, and to be honest I have no idea. I just know that that's something that we do in maths. It's something I'm going to have to look at a little bit more in depth, but for the moment just believe me that we do it, and I'll get back to the why we do it a little bit later. So let's just take 1 on root 5 as the example. We want to make the denominator rational. Now I guess there's a couple of ways, but the simplest way to make the denominator rational is to multiply root 5 by something. If I want to get rid of a square root sign, I can just multiply root 5 by root 5, because anytime you multiply something, a square root by itself, it will turn into just that number. So the square root of 3 multiplied by the square root of 3 is, I guess, the square root of 9, which just turns into 3. So the square root of 10 times the square root of 10 will just be the square root of 100, which works out to be 10. So the square root of 5 multiplied by the square root of 5 is the square root of 25, which is just 5. Okay, so by multiplying root 5 by itself, I can rationalize the bottom. I can get rid of the square root on the bottom. Let me just get rid of this work over on the edge. So back to this. Root 5 on the bottom. Now the reality is with fractions, remember, you can't just multiply the bottom by root 5. You also have to multiply the top by root 5 as well, because we can't actually change the fraction in any way. So I'm just going to multiply. Effectively, I'm just multiplying by 1, because root 5 on root 5 is just 1. So I'm getting a number and I'm multiplying by 1, and whenever you do that, it never changes. So on the bottom, root 5 multiplied by root 5 becomes 5, and on the top, 1 times root 5 is root 5. Now, where have we seen this before? We've seen this in our first topic, circular functions. If I take you back to this and I say, what's the sine of pi on 4? Now, some of you will start to freak out at this point, but we will do some revision on this a little bit later. To work out the answer to that one, we had our triangles, 1, 2, and root 3. That's one triangle. I actually don't need that one. The other triangle was this one. 1, 1, root 2, and that was 30, 60, and 45. Okay, now sine of pi and 4, I probably should use the one that we've been talking about a little bit more. I mean, you could have done pi and 4, but I'll say 45 degrees. We've done a lot more in degrees. In year 11 and 12, you'll deal more with radians. Anyway, back to the topic of surds. So sine 45 degrees, that's 1 on root 2. But sometimes in the textbook, it actually had the answer of root 2 on 2. Now, how do we get from 1 on root 2 to root 2 on 2? Well, let's just have a look. 1 on root 2 multiplied by root 2 on root 2. I'm going to rationalize the denominator. I get 2 on, root 2 on 2. So the textbook, what it was doing, and your calculator as well, it was always rationalizing the 1 on root 2 to be root 2 on 2. It's exactly the same answer. Both of those two are the same thing. It's just that we like to have this. It's the same reason that we don't like to have decimals in fractions and other weird tricky math things like that. We'd like to have it a certain way, so we'd like to have it like this. Okay, let me just get rid of all of this stuff here, and then I'll go to some of those questions that I've got down there. So hopefully this topic here, 12.5, actually probably draws on all of the other skills and things we've been working on in chapter 12, because things can get quite ugly when we're doing these sorts of things. It starts off relatively simple though, so that's not too bad. Okay, let's try a3 on root 7. That becomes, I multiply, that root 7 is the thing that I'm most concerned with, so I multiply by root 7 on root 7, and that means that the top will be 3 root 7, and the bottom will be 7 times root 7 times root 7, which is 7, which is that one there. Okay, which is just 7, sorry. So the answer is 3 root 7 on 7. I can't cancel down, and that's it. That's all I leave it as. Okay, let's have a look at the next one. Well, I can write that as root 6 on root 5. Now the issue that I've got here is the root 5. So I want to multiply both the top and the bottom by root 5. I don't need to worry about the root 6 because that's not in the denominator. It's just the root 5 on the bottom. So that becomes, well, I might be running out of room a little bit here, but that becomes root 30, because root 5 times root 6 is root 30 over 5. Now I always think to simplify. 30, will a number up the top go into that? Remember the numbers up the top, 1, 1, 2, 3, 4, 5, 1, 4, 9, 16, 25. Do any of those numbers up the top there go into root 30? No. So it doesn't. It's not necessary to simplify it. You can't simplify down. Can I encourage you guys to write these numbers somewhere? A lot of people I've been talking to as I've been wandering around the class haven't got this written down anyway. So I asked them, and it takes them a lot longer to think about it. So please write this down on the top of every page and on the top of the test when you get the test as well. It's pretty easy to write down all those numbers, but sometimes just having it visual in front of you is really good. Okay, so 1 on 2 root 2. Now with this one, there's actually two ways of doing things. You could just multiply both the top and the bottom by 2 root 2 if you wanted to. There's nothing wrong with that, and you'll get the right answer. The only thing is that you're going to have to cancel some of the numbers later on, because you're going to have 2's up here and 2's down here as well. Now the only thing that I've really got an issue with in this one over here is the root 2 on the bottom. So what I'm going to do, just to make things a little bit simpler, I'm just going to multiply by the root 2, not the 2 root 2, but just the root 2 itself. So that down the bottom, that will become 2 multiplied by root 2 times root 2, which is just 2 over root 2. So the answer becomes root 2 on 4. Now D, root 2 on root 6, I'm going to multiply by root 6. And the top one I'm going to multiply by root 6 as well. That becomes root 12 over root 6. Sorry, not root 6, just 6. Now I always think to myself, can I simplify root 12 by choosing a number up the top? Well, 4 will go into root 12, so that becomes root 4 times root 3 over 6, which is the same as, I'm running out of room here, 2 root 3 over 6. Oop, I'm running out of room. And that becomes, you can see the next bit, don't look at that just yet. The next, this bit is 2 root 3 over 6, which becomes root 3 over 3. Okay, so that's all we need to worry about for that one. Now as you can see, I'm now going to say you can either do questions 1 to 3 from 12.5, or you can keep watching and do the next little bit, which is something a little bit more complicated, but it shouldn't be too bad.